what we've done is separation of variables. We've done a substitution that makes a separation of variables. There's one type that we haven't done yet. It's the rest, okay? Everything else. Most things can't be solved with that substitution. That's a real unique one. Same thing with separation of variables. This is a more generalized one. It is going to look absolutely horrible to you the first time, but you're going to like these actually a little better than the ones you did yesterday. What you're going to need to do are really three things. The first thing that you're going to need to do is look for the form. You got to get this form. First and foremost, you have to get this form. dy dx, something y, something without y. One more time. dy dx, something with y, something without y. The coefficient or the variable or the function or whatever in front of the y here, we're going to call p of x. And then anything that doesn't have a y in it is going to be on this side. We're going to call function q of x. So the very first thing you do is reorder it so it looks like this. Pick off your p of x, pick off your q of x. Okay, so take a look at this one right here. dy dx plus 2y equals x. By the way, we couldn't use substitution. We couldn't use separation of variables. This is unsolvable the way it looks right now. But what I can do is I can say dy dx, something y, something without y. What's the coefficient of y? 2. 2 is my p of x. And then the stuff without y is on the right. That's just going to be x. That's my q of x. Okay, that's the first part. The second part that we're going to do is use a formula called the integrated factor, I of x, which is e to the integral of p of x dx. Huh? Where'd that come from? I'm going to prove all these after we've done a few problems. You'll never have to do the proof, but I'll show you the proof in a little bit. So, in terms of this, I of x is equal to e to the integral of 2 dx. What's the antiderivative of 2? 2x. So it's e to the 2x. E to the 2x is what we call our integrated factor. Great question. Of all time, I've always told you when you integrate, you have to do plus c. But not this time. Only this time because, I'm just going to tell you ahead of time, the integrated factor is multiplied by everything, which plus c becomes a power of e. And so it's like multiplying everything by k. And so if everything's multiplied by k, do we need it? No. So that's what the only time we don't need it, plus c. Great question. And then the last part, part 3. We're going to use this lovely formula, which is d dx of y times, now you don't know, well you do know this, this is I of x equals IQ. I of x times q of x. Now the way I remember it is, how many of you have ever heard of the Three Stooges? You have? What's their hallmark? What did they do a lot of, Max? They fought each other and they'd beat on each other, and you know they'd slap one and the next one would slap them back, and then the favorite move was the one guy was going to do the eye gouge. You remember this one? How many of you remember this one? So you're going to do the eye gouge, and what would he do? He'd put his hand up like this and block it. You know, it was great. So they did all these crazy things, but Mo, the leader of them, who had the little bangs haircut, he would always say, why I oughta, all the time. He'd do that all the time. Why I oughta, and that's what we're going to remember for this one. The derivative of why I oughta from the Three Stooges, and then equals you guys with the high IQ. Okay, so it's why I oughta equals IQ. The difference is this one is the derivative of this, and then this one isn't, which will have implications that we'll see. So now all we have to do is plug in the last part, which is the derivative of y times y iota, e to the 2x. We found that before, right? E to the 2x equal to e to the 2x times q of x, and we said q of x was what? X? Yeah, x. Okay. This is incredibly powerful. You just have no idea. So now we're going to integrate both sides. What's the integral of the derivative of a function? The function. So this is nice, y times e to the 2x. This one is not. How do you integrate x e to the 2x? By parts, yeah. And Anne had a big frown on her face. She had to do this. Yeah, I agree. So we got to make our little box here. And u dv, v du. I'm going to do the Lie-8 thing in my head. I know x is going to go here, and e to the 2x is going to go there. The integral, not the derivative, the integral of e to the 2x is 1/2 e to the 2x, but the derivative of x is dx. Crazy x marks the spot. And you're going to get y times e to the 2x equal to x over 2 e to the 2x, x 1 over 2 e to the 2x, minus the integral of 1/2 e to the 2x dx. So you have y times e to the 2x, you have x e to the 2x over 2. This is going to be 1/2. You're going to need a 2, so this is actually going to be 1/4. 1/4 e to the 2x plus c. There, Kurt, is your plus c. And then, if they gave you a point, which they didn't, we could simplify this. What I would do, this is what I would do at this point, is I would divide everything by e to the 2x. So this is going to be y equal to x over 2 minus 1/4 plus c times e to the negative 2x. And that's my answer for that weird first order differential equation. We're going to do one more example, and then the next video will have the proof. So the first thing you need to do, step 1, is get the form. dy dx plus y equals e to the negative x. Get it in that form so that this is p of x and this is q of x. So turn to your neighbor, tell them what p of x and q of x are. Go. Did you get that? Those two? Yeah. So we started out, Gabby, there's a format that we need to set this up. dy dx plus p of x times y equal q of x. And the reason for that is this formula is going to only work if we have it set up this way. dy dx plus something y plus something without y. The something times y in this case is boring. It's only 1. And this one is just going to be e to the negative x. You're going to like this. So now, that's step 1. We did it. Yay! Step 1. Found p of x and q of x. Next one, step 2. Now we need to find I of x. I of x is the integrated factor e to the integral of p of x dx. So this is just going to be e to the integral of 1. So this is just going to be what? E to the x. So my integrated factor is e to the x. For step 3, last part, we're going to go the derivative of y iota equal to iq. So the derivative of y times e to the x will be equal to e to the x times q, which was e to the negative x. What's e to the x times e to the negative x? I like this. Huh? E to the x times e to the negative x is e to the 0, which is what? Yay. Yeah, you can go e to the x over e to the x. That'll work too. Okay, now integrate both sides, and you'll get y times e to the x equal to x plus c. So then my answer is x plus c over e to the x. Did we solve, Soraya, our goal of finding what y was? Yeah. Yep. And that was it. I don't think I had a point. Oh, I did have a point for this one. 0, 1. So we can find c for this one. If this is 0 and this is 1, what's c going to be? C is going to be 0. E to the 0 times 1 is 1. So I think c is just going to be 1. Love it. There's your y function. We satisfied it again. That is integrated factor, finding the y function algebraically. Amazing.